Hello. All right, we're going live. Uh, so, uh, Hello, my name is Goran Mekic, and I'm going to talk about uh, a little project of mine called CBSD. And today's topic is going to be uh, when you see in a web little terminal. Uh, that's probably has something to do with WebSockets. So, as this project is partially about web, and that is front end has to be able to communicate with the rest of the system, and one way of communication is, hey, what's going on? Give me your output, right? And it has to be in real time, so it's kind of obvious that what you need is WebSocket. When you say anything real time and web, it's probably about WebSocket. So we're going to check out what, how does it look like in a current state. Okay, let me see. This is a bit smallish. Okay, so when I type, you can see it. Okay. Uh, so first thing, yeah, I should really fix this one. So here's an error, uh, and it's undefined error. It's even worse. Oh my god. So what's going on is that when you peek into the workers, there's okay. Let me refresh. So this is what happens, right? This little nasty thing. And what it's trying to tell me is that I should actually run the proxy uh, so that backend has someone to communicate with. All right. I have no idea why this became white all of a sudden. Oh, hello. So there's a list of jails, and one is virtual machine because it doesn't have a subtitle. I know it's virtual machine. Actually, I know it from the data, but visually it's like this. And I obviously didn't pay much attention to the UI currently. So if you're looking at one of the jails, did I switch? No, I didn't. Damn it. All right. So what I was saying is that this is a virtual machine because it doesn't have a subtitle here. And once I do the UI, it's probably going to be different cards or something like that for or icons maybe. I don't know. Anyway, it's a list of instances present on your system, and when I try to store it, I think this jail isn't stored. All right, so it does this. Oh my god, this is not nice. No colors, right? But the output is right. I mean, it is the output of starting a CBSD jail. And this is what happens. Now, when you try to stop it, this is what you get. Okay, now, uh, what you don't see is um, like a notifier, either a spinner or something, just so that you know that command has finished or it's still working or something about it. Anyway, it's not nice because there's no color. And how about now? All right. Now, the CBSD is practically coloring stuff. And what happens is that I'm not completely satisfied, but it's okay for now. So this is what happens. You can see here it actually says E pair 5. This is what is called the ANSI color, the escape sequence for a color. And when your terminal has colors, that's because it's interpreting these strings and it knows what to do with them. I'm not going to go into what they mean and how they work. It's just that you need to know that if you have a colored output in your terminal, that means before that output there's something like this 133 something something M or whatever, because the it changes with the color. Is it for the background or the foreground or the text, the font, and so on. And now, if you know how the CBSD output looks like, this is actually not completely correct, because all of this, wait, at least all of that should be in the same color. But the reason it's not is because I'm parsing line by line. And you can see that here. If it's in the middle of a string, I won't even notice it. But the coloring works, the initial foundation is here, which means I actually know what I'm doing with the colors of the terminal, how to um, put them into the web, because the color syntax is totally different, right? And what is going on here is that going line by line, if this, for example, if this line is colored and this one is not, actually, this also has to be green, I think, when there's a uh, color sequence and there's no reset color here. This shouldn't be white, but in terminal it should be green. And this is what I'm still working on. So it's work in progress. And let's see what's actually going on here. I mean, inside the code. So I need. All right, I need this one. So let's start with the front end. It's much simpler. No, I'm lying. It's all complicated. Everything about the WebSocket is complicated. But let's start with this detail. So this is what the toggle does when I start stop the jail, and basically it's using uh, the REST API to either start or stop the service, and then with the handle the error, and then somewhere it's going to talk to WebSocket and listen for the answers for the output coming from the backend. And this line says, okay, my list of lines, my list of messages you should display in a terminal should be an empty array. Otherwise, it appends messages all the time, and it's just easier to read it like this. So, what's going on here? For now, uh, I just say, okay, put messages from the socket uh, are actually of array of messages. And ideally, every message represents the line, and that's not true. So, one of the reasons why coloring is not working perfectly is here. Actually, it's all here in like 10 lines. So, if that line has a certain type, just okay, there's some either error or exit or otherwise connection closed, and we just don't want to do anything when that occurs. But when it's a, let's say, a normal type of message, and there's a payload in that message line, right? First, we need to make it safe. That means, for example, is output, and if config does contain that, has how it's called, the less than, greater than signs, then the parsing is gonna blow up because it thinks it's HTML normally, and we have to make it safe. Then this is a cute little library that gave me an inspiration. ANSI span. For every ANSI color, it creates a span, and then it has multiple spans for just representing the colors, and that's a cool way to represent this. But then, because when we have an array, which we have here, we are mapping to array all time. We need to have a key, and to inject the key into this ANSI span element, we need to parse it, then replace some of the, well, it's called replace, but I'm actually adding uh, the what? Oh no. Okay, so this is an error. All right, and if there are some attributes, I convert them to props, and then I enter the key to the prop. Uh, this is a really dummy key, but I don't know what else to do with just a line of output. Maybe generate the date on the back end. I don't know. But for now, this works. And we display it in this element that has a style as a terminal, and that means background color black and color white. That's the rest is not important. So this is what happens in a front end uh, page, but um, because we have a socket here, is going to listen to the messages incoming from the WebSocket. And just where is it? Okay, I'm blind. So first, we're going to make a socket, and we're going to put it in a separate file, uh, because this is the way to make a socket only once. If we create it like here in a store, then unfortunately uh, it's going to be called multiple times. There are going to be multiple objects of this socket store, and we want only one WebSocket. Otherwise, you get multiple messages, like doubled or tripled. Uh, well, depending how many sockets you created, and that's one of the reasons. Actually, that's the reason why it's in a separate file. It's created once and that's it. Uh, from other places, it's just imported. It's not created. Now that's beautiful, but I had multiple messages even with this, and the reason is that I registered my. Well, this is a really dummy function, but I register it when there's a message of type output execute this. And although there's only one socket with this, if you don't do this, this is going to be registered multiple times. And you get multiple messages all over again. So maybe there is, maybe there isn't a handler for the messages of type output, but whatever there is, just turn them off, all of them. Whatever is registered and then register it again. Uh, this way, whatever object of this class is created last uh, is going to be the only one that has a socket registered with this method. And this is part of a reason why I hate WebSockets. Actually, you have to really dance around them. They are not so nice to work with as other technologies, but I guess that's the reason why I'm talking about it. I mean, because it's not the easiest thing. And I hope you're going to remember this, because having just one socket, that's WebSocket. I mean, that's the hardest part of this uh, project, I'm afraid. And there is even C and C++. So it's really not nice. All right. So what happens here is that we have just a classic store which stores messages, and these messages are just an array. They're actually going to look like this. Uh, right? But at the beginning, it's an empty array, and we just store messages as they arrive from the backend. So, just a sec. This is not interesting. And this messages will be array that is getting appended as the WebSocket is sending messages. It's actually going to be emptied at the beginning of every command. Start and stop for now, but that's what we have. And then all the messages are going to be appended. This is how you append the message. So, uh, how does it work in the backend? Is nothing nicer, I'm afraid. So, oh no, the thing with the backend starts at the development, starting the command itself. So first, you need G event, and it tells it to create 16 cores. I'm not sure what the G event core is. Uh, I need to read more about it, but there are 16 of them. It needs to be multiple, right? There is monkey patching, and it's not called monkey patching for without a reason. There are some um, how to say libraries in Python that needs to be patched for WebSockets in Python to work. The problem is, the problem is that you have one thread active at one time. Even if you have multiple threads in your application, only one is going to be active. And while the thread is not active, listening on a WebSocket message, that message can arrive and is not going to be notified that thread. Hey, there's something on your input basically, and it's gonna miss a lot of messages, or at least some of them. But it doesn't matter. It doesn't work reliably, so it needs to be monkey patched. But this monkey patch only needs to happen to be done in backend or whatever is running the WebSockets. So we need to patch it first, tell it that it's going to use WebSockets because it's development reload when something changes, and because of the uh, debugging, we need input or the keyboard to work. So this is what this command does. And then this is what is what's initializing the application. So we have this initialization here, but for WSGI we just have this. So there's a difference, and let me show you something else. This actually is what enables you to either run WebSocket or not. You don't want background workers to have a WebSocket, so the worker here says false. Otherwise, you have two WebSockets or multiple. Uh, so most of the time, what I did is like I have multiple WebSockets. This is a problem. So you need to initialize so that WebSocket is either created or not, and otherwise it needs to be identical. So when that happens, the create app If there is a WebSocket, it's going to uh, open that WebSocket and is going to start the thread listening uh, for uh, for Redis messages, and then it's going to uh, push them towards the front end. Now, how that happens is that first, if we look at the instance start, uh, through URL, we're going to tell it to either start or stop an instance with this name, and we're going to delay this execution. That means that it's going to be run like this start command, but with this dot delay, it's actually going to be handed over as a message to the Redis, and that Redis is going to move it to the Celery, Celery, which is going to run a worker with this function, right? So it's going to um, transfer only the instance that needs to be started as an argument, and then other process is going to get that message and do something about it. I'm gonna show you in a second. And this is all the REST API does. It just starts the command and returns basically nothing. Um, but when it happens, uh, oh yeah, this is probably hmm, yeah, this probably moved. Okay, so this is what we're doing. Uh, we're going to create an instance. Now, this is not the same process as a web worker. This can be on, well, Celery can be on a totally different host, but basically we know that uh, our worker must be where the CBSD is, so it can talk to it via Unix socket. But REST API can be on a totally different machine communicating with this one through Redis and Celery. So we create an instance with these parameters and we just start it. And the instance start is going to do all the magic actually. Magic being. Give me just a sec. Okay. So it's always do something and execute it. And execute is going to read messages until the type of message is one of these. And it's going to, whenever it receives a message, it's basically going to convert it into dictionary, then into JSON, put it into a message, and through Redis is going to publish it for the that thread I talked about, uh, listening for Redis messages that pushes um, towards the front end. The reason is that only one thread must be listening on a WebSocket because of the pro- limitations of the technology. So we have to have one thread doing all the WebSocket communication and pushing messages towards it using other means. In this case, that's Redis, but basically we're using one channel for messages between the Celery worker and WebSocket worker. but and we are using the other channel for messages between front end and back end, and that WebSocket uh, worker. And this is basically how it happens because command.send is sending just the raw message. It's how it's received. This is how it's sent. And yeah, sending bytes in Python. This is not really self-explanatory. Um, because of the proxy done in C++, it has types, right? I mean, even if it doesn't, there's exact amount of bits that needs to be transferred to represent any number. It's either 32 bits, 64, 16, whatever. And the proxy has unsigned 32-bit type uh, for ID type and the size of the payload, so the length of the payload. And the payload itself is just a string. Converted into bytes in Python. I'm not sure what happens when it's bytes and what happens when it's string. But basically, we're converting this payload into bytes and sending it. And because 32 bits has well, every byte has 8 bits, that means that 32 bits have 4 bytes. So you need to tell it, okay, this is a number, but represented with this number of bytes, right? And that's not enough because mm, machines can be big and little endian, and that means uh, that bytes are put into memory either, well, let's say from right to left or left to right. If you draw memory like a huge array of bytes, which it is, and so that's the most significant number, the digit in a number is on the lower part of the memory or higher, right? It's so it's big or little endian. And in order to have no idea which byte order it is, you just use this one. Uh, why now this is going to work? Because the proxy and the worker have to be on the same machine. So it means it has the same byte order. Otherwise, this wouldn't. I would have to. How network does it, because we have different machines and yet we all communicate through the internet, is that everything is converted into one endian, and then machines with the same endian just say, okay, cool, this is uh, uh, this is exactly the data I was looking for, or I requested, or it's okay, I need to convert them into my endianness and then use them. So this is a little trick, little how to say, pitfall that you can find yourself in when you're working with exact number of beats, bytes, and Python. So this is what's going on underneath. So execute just sends the command and then reads until something happens. Either an error denoted by -1, either connection closed, or the program on the other side, or the CBSD command, uh, finished. All done nicely, and just the command finished. Uh, so either of these just break the loop. I should handle this and transfer it to the front end, but as you can see, I was still dealing with the colors. Not having these things was nitpicking at the time, but uh, yes, every message needs to be transmitted to the front end so it can choose what to do with it, visually or some actions or whatever. But yeah, this is how it all ends with either normally, some abnormally, some connection closed, or -1, so something terribly happened. The the types are basically these, and what I'm doing with this is okay. This is easier actually. Message has okay has these three things: ID, type, and payload. And type can be one of these. And the types are ORed together to form a final value. And I'm still sending it as a single type, right? I'm not this or that doing, but I know I'm gonna have to soon. And uh, I mean, you're not going to see any or in my code yet, but this is a neat trick how to know you can do that, because when you convert this into binary, and if you don't know how, that's your homework. When you convert all these values into binary, you can see that they are okay. They are all zeros. I don't know how many zeros there are. Doesn't matter. But none is going to be this. No color is going to be this. Jail is going to be this. Uh, what's next? Beehive. Uh, exit. Right? So you can see that single one is going from right to left. That's how the values are composed. So if you have, uh, let's say, what was this? Beehive and no color, you would basically have this as your final type, right? So bits represent what we want. And this is how the backend and proxy are communicating. So this is how they communicate, and this is how the stuff is returned from the backend towards the front end. Uh, the tricky part was always, and I can't emphasize it enough, is to have just a single WebSocket connection between front end and back end, and that it's reliable. Uh, you can have, for example, multiple WebSocket workers, because only one needs to listen on a WebSocket, and I mean, it's done differently than the regular sockets, so it's decades newer. So there are still some problems with it. And when you're scaling sockets, that's a wonderfully complicated story. With MicroVisG, for example, you can scale HTTP workers, so what works with REST API, and you can map a single worker on a socket that is going to be used only for the WebSocket communication. Now, when you need to scale multiple WebSockets, what you do is open multiple ports and map each worker to a port. Now you can see it's not so nice to configure Nginx, for example, or whatever your load balancer is, uh, with that in the backend, right? So the story with WebSocket is not ugly only in development. It's not getting nicer in production. So it's something I'm going to moan about, especially because security of a WebSocket is a absolute nightmare. Uh, I cannot tell my backend, let everyone in for 15 minutes unless they send you a token, a new token through a WebSocket. So you have to ask your clients, can you send me the blah, 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 blah. You have to work around it. It's not impossible. It's just really not nice. So I'm always looking for a better way to manage the WebSocket. And if you have any idea, please leave a comment. Um, the global interpreter lock with Python doesn't help, but even without that, it's really not nice. It's there are so many ways to screw up. It's you probably don't see the next error, and that's why I don't like him. Anyway, that's the technology we have right now, and that's what we can use in a browser. So we are where we are. Uh, that would be all for today. For the next week, I really, really hope I'm gonna have the time for uh, C++ shell and code, the command completion and coloring and nice stuff in the terminal, unless there's a really nasty bug with, or doesn't even have to be a bug. Uh, I need to type something into the web terminal and it needs to be transferred to the backend through the WebSocket. And if that ends up being a pain in the neck, then it's going to be a talk about WebSockets again. I really wish you don't experience that. But yeah, it's either going to be how to avoid the problems that I found with handling keyboard input and WebSockets, or it's going to be how to handle well the input in a terminal shell with the colors and completion. Until then, take care and bye bye.